Welcome to this 88K model railroad video, and this is a modification to the field fix video, and I'm going to call this part 2A, and it's in reference to the automation requirements that Rocrail has. In order for the transfer table to be automated, it needs to know when a train enters into the bridge and when it's actually in the bridge. So there's a requirement for two sensors, and I had to figure out a way to get those two sensors on the bridge and operational, and that's what this video is about. So with that said, let's take a look at the wiring and the wiring diagram, and that way we can get an idea of how it works, and then we'll go through the process, and we'll then finish things up by actually looking at it operate. So let's get started. With the original pit, we only used four terminals. We had the cab, which had the decoder installed in it, was supported by rails or terminals 2 and 4. The rails for the bridge itself was supported by terminals 1 and 5, and terminal 3 was not used. In this case, we're going to add the additional rail segment, which we're going to utilize terminal 3. So let's look at the electrical diagram. Here's the basic wiring diagram. In rail number 1 is supported by bridge, and we're going to call it rail 1. That is a negative terminal. Then rail 2 is the decoder's negative side. The third rail, or the center rail, that's going to be our first current sensing device, and this is going to be rail 2A of the bridge. Then the positive, which is going to be positive. Then the rail 4 is the decoder positive, and then rail 5 is the bridge rail B positive side with the current sensing device installed in it. So you can see here on the right, this is the basic wiring. I'm using NCE's BD20, which is their current block detection device, and I've got that wired in. It uses a coil induction in order to monitor or detect current flow. So when the train enters into that particular block, it starts to draw current, and then this device will send a signal to the ESP32 and Rocrail, and then we'll send it to the controller, and then update the or Rocrail's program. So that's how this is wired. And now let's look at the process that I took. So fortunately, I was able to get the base or the block on position 2 of the bridge. I was able to pry that up and remove that that one square piece. That allowed me to get access into the bridge. Then what I ended up doing is cutting the rail right in the center, and I remounted the rail, I'll call it 2A, on the left side. I mounted that back onto the bridge, let it or glued it back, and that way it wasn't flopping around. It wouldn't break the wire, and then I would have to go in and rewire it. That would be a mess. So I took my time, re-glued the rail down so I wouldn't have to worry about it. The next, on the right hand side of the bridge, the right adjacent to the original or rail 1's hole, I drilled another hole, and that gave me access to the rail to channel the wire back to the center of that block 2 or segment 2. So with the rail in place, after drilling the hole, I ran the wire up to the rail, and I soldered it from the rail, on top of the bridge, instead of instead of soldering the rail to the wire and then trying to run the wire through the body of the bridge. I did it the other way because it's easier to fish the wire out and up instead of trying to channel it in. So once I got that piece of wire ran, then you could see here I drilled another hole in the block and ran the wire to a screw and nut, and then that gave me a terminal to connect to. Then I remounted the block, glued it back in, and I made from a piece of copper not a feeder but a pickup, and I made it like the L shape you can see, and I bent it so it would make contact with the rail, and I screwed that in. So now that gave me the connectivity from the rail on the bridge down through the bridge, and then to the terminal, and from the terminal to the pickups. So once that was done, I focused on the pit, and I took the same process. I soldered the wire onto the rail, and from the rail I reinstalled it in the pit. With the hole drilled in the pit, similar to what we did earlier, I reconnected the rails, or I'm sorry, not the rails, but the power feed to the rails, and you can see where I channeled in all of the BD20s. I looped them in, connected them to the terminal, similar to what we saw in the diagram. And from there, I was able to go back, test everything, and the connections, they were all, or did a continuity test, that's the best way of saying it, and everything checked out. With that completed, I conducted a complete test with Rocrail, and everything tested okay. It went into the block and back out. So we can end this video here. Hopefully it helps you guys out in setting up your bridge if that's what you want to do. And as usual, like, subscribe, and we'll talk to you guys later.